All right. Hello, everyone, and we're back with another live stream. The past couple of weeks didn't really have one because there were actually the past couple of weeks. Yeah, there was one 2 weeks ago. Last week was an Incus release week, which happened while I was traveling. So the video for that came out earlier this week instead. But yeah, back to IncusOS, back to live streams for a tiny while because I'm gonna be traveling, like taking some time off in not next week, the week after. So there's still gonna be another live stream next week, and then it's gonna be a little break for a week or two. Anyways, I wanted to touch on the state of Incus OS because it's been a little while. The last live stream was not on Incus OS; it was on normal Incus development. So it's been a hot minute there since the last time we've been looking at this, and quite a lot has changed. So let's go back a bunch to where are we? More than 2 weeks ago, basically, because that branch had not landed yet. Yeah, we might have been. I mean, USB, the USB IP stuff was the last work that was landed. Where is that? I'm feeling like we're getting a bit too far. Oh, there we go. USB IP. Okay, so that was the last IncusOS live stream all the way up there. Let's look at roughly what has changed since. So we did a bunch of work towards Operation Center and getting registration, clustering, and everything in place, which required a few small changes. So that was one of the changes here with this pull request to add tracking for management address and interfaces. That came with the registration functions for Operation Center, which then allows for IncusOS to boot and auto-register in with Operation Center, and then also do background updates if any of the IP configurations start changing. Then some more tweak around network state, did some cleanup to really lighten the number of units and services starting up on first boot. I'm going pretty quick through some of that because I'm pretty sure I covered that in the stream, which was not really supposed to be about IncusOS, but I still covered some of that 2 weeks ago, basically. So it was still that cleanup, more units being disabled, tweaked the definition of online to actually wait for DNS now, and fixed a couple of bugs in the API. We added license checking to make sure we don't pull incorrect dependency by accident. And then comes the big PR from Matthias, where we add the new secure boot handling. So that's new, and that's actually part of what I was presenting last week as well, when I was at the Linux Security Summit. So we basically added a bunch of logic to handle detailed secure boot PKI handling effectively. So what that means is we now directly track what is in the platform keyring, so that's PK, in the key enrollment keyring, KEK, as well as what's in the signing keyring, or DB. Up until now, macOSI, what it does is during the enrollment phase of IncusOS, it just enrolls the same key in all three. We are changing that by having a full PKI with, actually, let me just find my slides from last week. It's going to be easier. There's going to be a YouTube recording of the talk I gave, but I can give you a quick glimpse at that. If I look at Linux Security Summit North America, Incus OS, there are those slides, and I drag those up here. There we go. Okay, so if we look at the PKI side of things, it's here. So that's what we generated. We generated a root CA up here, which then signs two intermediates, one for updates, one for secure boot. Right now we care about the secure boot part in the commit I was showing. So we've got this certificate, which is kept offline and is just used to sign new stuff. and then it signs a platform key certificate, a key enrollment key certificate, and then it signs a yearly key, so 2025, and we'll have one for 2026. The plan is that on first boot, we attempt to enroll this key. That should fail on production servers because they will already have a platform key, but we still attempt it. Then we enroll this key. That should work so long as the machine is in setup mode. And that key we really want to see loaded. And then we enroll the current year's key. With this key, we can sign an update to replace a yearly key with the next one. So that's how we're gonna do every year key rollout to a new key, keeping both of them valid for a little while, and then once all the images on a given system are signed by the new key, we can revoke the old one by adding it to the revocation list. So that's the plan on that front, and we also have a separate set of keys for the update server. So that's what signs the actual update index files and individual update files. So we've got that on the image server as well. So that's basically the new keys. And so that commit, the set of commits I was looking at here, they put a lot of that logic in place to check that we've got the right keys in all of the right databases, handle the key updates. So having the KEK sign an update to enroll the next year's key effectively, and then keeps track of what image are signed by what, so that we can put the revocation entry, so dbx, once no image on the system relies on it. And that lets us do two things. One thing is now every year we get to roll to a new key. So if a key somehow gets stolen, leaks, or whatever, chances are it will have been rotated already, not a problem. The other thing is to handle compromises. So if one of the signing keys actually gets compromised, then we can quickly use the KEK to sign another key and then go and roll that out. The trick with setting up a PKI kind of that complex is there are a bunch of keys in there that need to remain offline at all times. Basically anything other than the yearly signing keys should never be on an internet connected machine. It should always be kept fully encrypted, split into different chunks, and really avoid anyone from stealing that. Because if they can steal those, then it's basically game over. You can control all of the IncusOS systems. And if if the KEK or some of those keys get compromised, there is basically no way to rotate them to replace them, because the firmware, like the actual physical machines, will not let us update that without it being signed by the platform key. The platform key comes typically from the manufacturer. We can't do that. So it would effectively require manual action from the user to go in their firmware, switch back to setup mode, and then boot the system to fix the keys. So anyway, we wanted to really have that logic, and we're actually now in the process of moving existing users from the initial set of keys to the new setup. And that's good because it's actually a setup that's pretty similar to the compromise rotation case. So we get to effectively experiment and make sure that the logic behaves the way we want it. But that's quite a few commits to actually keep track of everything. We also need to predict what some of the TPM state is gonna be when booted after the update, and to make sure that the disk automatically unlocks and there's no prompt for recovery keys, all that kind of stuff. So quite a bit of complexity. We've done a bunch of testing. This has actually been live now for a couple of IncusOS versions. Anyone who updated on that would probably have seen their machines reboot 3 times in a row, because that's basically how many steps it takes to update everything. But that's been working pretty smoothly. Then what I've been doing since, that's some more follow-up from this one, doing some tweaks to just fixing some tiny bugs here and there effectively around Operation Center. some more bug fixes. We noticed that we didn't have proper handling of the recovery key on the swap partition, so we got that fixed. The UI will occasionally show a weird error around the main network interface, so we fixed that so that that goes away. Then more logic to handle disk encryption and kind of validate. Well, there was a kind of race condition, or rather an issue, where after applying some applications, we couldn't get the path to the encrypted volumes anymore. So we've effectively shuffled some of the logic, so we have that working again. And then we've added the logic to actually pull the secure boot key update, so trusting the new keys. That's when we added that. At which point, when we tagged after this one, it was the first time all of the existing systems effectively enrolled the new keys. And then we've got, okay, that's just a small fix from yesterday. Another change that landed yesterday is we changed the way we store persistent state from being a JSON file to now being our own key value-ish file. The benefit from that is if we change the structure within Go, we're not gonna have a problem if we, like, part of the issue with using JSON was that if you serialize and deserialize and then you change the struct, then eventually you can't read the file back and you effectively lose all the state. That would be pretty bad. We didn't want to deal with that. So we've got our own basic kind of key value on disk storage now, which we know we can always read. At worst, we're going to lose like one config key or something like that, but we're always going to be able to read it. And we can also do backups and all of that pretty easily if we fail to read something. So that was to kind of future-proof our updates to avoid any kind of issues. So we've done that work. And then yesterday I landed the support for our new image servers. So I mentioned a couple of times we're gonna move away from GitHub for actual image distribution. That is done now as far as of this code being live. Speaking of, actually need to move some stuff on the image server right now so that a demo later will actually work. Alright, so just moving things into place so I can run a quick publish on the server. But let me just switch user there, export, publish. Okay, there's a publishing running right now. But if we go at images in xcontainers.org/os, we can see there's an existing image in there with index file, signed index, all that kind of stuff is all in place. I'm just publishing a new image because this one is outdated and should be live hopefully in a few minutes, or maybe right now already. Yep, there we go. So we've got the new image here, which we're gonna need for the demo just afterwards. And yeah, we're effectively doing the transition now from using GitHub as the way to handle updates to using our image servers instead. And then the next step is to actually switch the signing keys on the GitHub side to sign with the new key, and then do the publishing. We're just trying to do things in a way where we break as few users as possible, so that in general you can actually just update from one version to the next, and it did the secure boot rotation already. Now it's doing the image server rotation. The next one is the image is actually signed with the new key, and that should work pretty smoothly. There are a couple of cases we're aware of where basically we can't do any more GitHub releases once we've switched the keys, or we're gonna break the upgrade path from existing systems. That's annoying. We do want to use GitHub releases again, just to have a way to do proper announcements and whatnot. So we know that we are gonna start using them again, and once we do, that's gonna break any system that has not updated. The idea is to basically wait a week. So for a week, we would only use GitHub tags that are not gonna cause any issues on existing systems. We're leaving that week for existing systems to have pulled a new update that effectively would make them aware of the new image server. And if after that, nobody has actually, well, if you've got offline systems that you then try to update later on, they will fail. They will still be running, but they will fail to find any new updates. And that's kind of unfortunate, but at the same time, we keep saying that this thing is not even like in beta yet, so it's fine. Like, we're not gonna feel too bad about potentially breaking some systems that are currently offline. All right, just saw a couple of questions in the chat, so we're just gonna go look at that. So a question from Jared: if I was to deploy Incus OS on bare metal in someone else's data center, I guess, then I guess I would have to go there myself and do it myself. It would not be enough to ask them to do it for me. Not sure what that part refers to. Like, I mean, deployment in a data center, normally what you have on servers is some kind of out-of-band management technology, whether it's Dell's iDRAC or HP's ILO, or just like a generic Redfish API, OpenBMC, something like that. If you have that, then you can go in the firmware, you can switch to secure boot, put it in setup mode, and then use the virtual media to make it boot from the ISO, go through the install, enrollment, and everything, and then you're good. That's what we do for our customers. Like, we usually get VPN access to the management network for those servers. We access the out-of-band management platform and either deploy it by hand that way, or we use Terraform with a plugin for the given vendor to then go and deploy that way. And there's another question around whose idea was it? Oh, okay. Okay, and was saying that he's mostly used, Jared is mostly used to AWS. Yeah, with the cloud providers, obviously you get provided VMs technically. So like, if you're for those, it's gonna be actually kind of interesting if anyone ever wants to run this stuff in the public cloud. So effectively doing nested VMs. That should be okay, but it's gonna depend on how much control they give you. Again, like some of the public clouds, they don't give you a ton of control. You don't really get to easily go into the virtual firmware or mess with stuff that way for their VMs. But then other cloud providers do, like anyone who's running basically on top of OpenStack or something typically provides you full access to the virtual machine firmware, so you can even do all of the secure boot stuff if you wanted to do that. But yeah, it's quite different, obviously, if you're used to deploying stuff in the cloud with AWS, Google, Oracle, Azure, or whatever, and you're not used to doing it on physical servers. On physical servers, there usually is like that BMC that we can use to see what's directly on screen, interact with the server, push firmware updates, apply BIOS and other firmware settings, and add virtual devices. So usually they let you either you upload the ISO and then that shows up as a virtual USB drive, or some of them you can actually give them the URL to an ISO and they will do the downloading and stuff themselves. There's a bunch of different options, but that works usually pretty well. Once I get my lab kind of back together here, because some of it is not working and I'm moving stuff to a different building, so it's going to be a bit bumpy for the next few weeks. I do have those 3 AMD EPYC servers that are identical. They're all 64 cores, 128 threads with a bunch of RAM and whatnot. So for those, I was hoping to actually do the full setup at some point in a video where I show the BMCs. So they're using OpenBMC, where I can use the virtual media, upload the ISO, and install them. I think their BMC requires a micro SD card for the virtual media, and I don't think I've put one in those servers, so I'm probably gonna need to dismantle them and actually add some stuff, but in general, that should be possible. And okay, Jared is asking around Hetzner, who are saying that to deploy that on top of Hetzner. I'm trying to remember with Hetzner, I think either they have an add-on to get access to the to the actual, like a KVM add-on, effectively, to see directly what's running on the machine, like on the physical machine. So that might be an option to do some of that. It kind of varies between the providers. I've not used Hetzner in a little while for physical servers. I think the most recent one I did was OVH, where it was effectively an add-on to then get access to the BMC. But in general, when you're paying for renting physical hardware, they often have a way to actually get you to see what's actually happening on screen and have effectively direct access to the hardware, because that's needed to install some of the operating systems. All right, so that's basically where we're at. Now, as I showed, this has been deployed. And we still have GitHub releases. So if I go here and I catch the one from an hour ago, I should be able to download the ISO and then add a seed to that, and then go and deploy it inside of Incus. Okay, the Flasher tool hasn't been updated yet for the new image server. So it will still download stuff from GitHub right now, which is fine. I mean, I just did it here, whereas I could also have gone and effectively downloaded the exact same file from, oops, this one, the second one. I could have downloaded it from here. It would have been the same file. Okay, so let's see. Can we get this stuff up and running? I'm really hoping the image server and everything works, because it's the first time we actually publish an image with the new logic. I've done some local testing, it worked, but okay, well, that's quite a mess in here. But I've not actually done it myself. So let's see, ISO GZ. Let's unpack the ISO, and we'll just want a basic seed that just tells it to auto install basically, and should be fine with that. Okay. So let's see, I've got the seed folder, I think. Okay, well, this one's a bit of a heavy one. Actually, never mind, I can do something different. Let's move that ISO, because I did a demo at the conference. I think I still have the files for that, so let's do that. Yeah, I do. Okay, so I can remove the old file from last week, and we'll use the new one. And I've got a demo.sh script I was using for that, which effectively copies the clean ISO, adds a basic seed, creates a VM from it, started, which is exactly what I want to show you now. So let's just go ahead and try that. Okay, so that just created the VM, and we should be able to do demo OS console. That should do the enrollment. Yep. Console demo OS, and I'm gonna need to unzoom things a bit. There we go. The install should work perfectly fine in any case, since that doesn't actually talk to the update server. It's after reboot where we'll actually see it download Incus OS, the Incus application from the new image server. Okay, so device remove, demo OS install, and then can start it back. Okay. Get a few seconds to actually boot up. There we go. For those who didn't install it recently, that's actually been a change where we have a clear auto-generation step for the encryption key, because otherwise it was just causing some delays and wasn't very clear what's going on. So we fixed that. And let's bring up the network. Here we go. And that download is now happening from the new image server. And let's bring Incus up and running. There we go. So that's basically the current state of things. That's using the new ISO that I could have downloaded even from the new image server instead of GitHub. That's connected to our image servers to download the Incus update. And then from this point on, it will effectively apply updates from that image server. So that's all looking pretty good. And at this point, we should be able to actually start looking at what I wanted to do in this live stream. Alrighty, so let's just go back to here on GitHub and look at the issues. So there is this guy, this task, clean up network roles. So that's what I want to do. We've got support for roles in the API currently, but we don't do anything with it. So basically, when you configure a network interface, you can give it a set of roles, but it's just a string that we store and we don't do anything with it. That needs to change because we cannot need that for Operation Center, at least in some situations. So we want to kind of standardize it. The first thing is we need some validation. So we're gonna have set clustering, but I think we probably want cluster instead. I'm not sure what's going on with GitHub today. They changed something in the UI and it's not liking. It's not looking particularly good. I had that issue earlier too. Let's just save that. There we go. So we want to make sure it's one of those three. When we do validate roles, then we want the roles to also be visible in the state part of the network API, so that we can easily see not just what was configured, but what's actually applied. Yeah, there was more clustering stuff I missed. Let me see if I do a force refresh, maybe the form will look fine. Yes, okay. So that was the issue. Let's just do that guy here. Okay. So effectively, we want to expose the interface role in the state and then add some logic so that we always have an interface that's tagged as management and cluster, even if nothing was set by the user. That means that then within our code, we should be able to easily say, hey, I want to know what the management interfaces are or what the cluster interfaces are, and we'll always get a response. That's useful because now with Operation Center, what we're getting into cluster configuration, especially setting up tunnels, setting up where the traffic should go for things like oven. And with those roles in place, it's very easy for us to configure that. Without them, it's a bit of a mess, and we need to do it by hand, which doesn't work very well across multiple systems. All right, so let's just look at how things are right now. So if we disconnect from this VM and we go inside it, so demo OS, and just do query OS 1.0 system network. So here, just clean that up. We can see the default config we got is basically stateless autoconfig IPv6 only in this case. And this one actually did put the management role directly in the config. So we can see it's here. Now it is not visible here. So that's one thing that needs to be done so that the roles effectively propagate from up here to in here. But then, as you can see, the cluster role is not set. And the logic is should basically be if no interface has the cluster role, then whichever ones have the management role automatically get the cluster role. So I need to put that in place too. So it's just like a few steps to kind of clean that stuff up. Figure that would be something interesting to just show on the stream. So let's go and start looking at some of that logic. So Incus OS, just making sure it's up to date. Oops. Oh. Yes, okay, good. Then rebase my branch, make sure it's all nice and clean, good. And the first thing we're gonna wanna do is the validation. So I'm trying to remember how much validation we actually have in place for that stuff already. I guess it's not a whole lot, but if we go in internal, it's probably REST system API system network. So what happens when we do a put and patch are here. We do the marshalling. So that's kind of basic validation of like, does it actually line up with the struct? And then we call apply network configuration. So that's where validation should be going on. Apply network config, this guy. And apply network config calls validate network configuration. So that's what we need to look at next. Here we go. And that does validate. So interfaces, bonds, VLANs. Okay. I wonder if there's like a common validator. This would be kind of annoying. Forgot to do it 3 times. What does the bonds do? Okay, it's not defined here. Validate bonds. Okay, there's a separate file for validation. Good. Validate bonds, there we go. It's going over the bonds and validate name, validate mode, validate MTU. Okay, so there's a bunch of different functions for that. I don't suspect there's anything validating roles. There's not. So sounds like we need, just like the validate MTU, we need a validate roles, bond.roles in this case, bond, whatever. Okay. Yeah, it's a bit of a weird way to format things, but I'm not gonna get too worried about that right now. So that's VLANs. So VLANs also have that's fine. And then that's the interface. I should probably actually fix the error handling. Bond VLAN. Oh, whoops. That's not gonna work well if I don't fix that one. Okay, interface. That should be fine now. Okay, and I just need to actually write validation logic for that. So validate roles. Roles is just a list of string. Okay. So I kind of want to do 2 things. First, deduplicate it. So if we find that the same role existed multiple times, we should fail. And the other thing is if the role is not valid, we should fail. So that's kind of what I'm looking at doing here. So we want to make strings. What's the done syntax for this stuff? Always forget. Yeah, 0 and then max. Okay. So 0 and the max is roles. There we go. So if it doesn't, actually I should do, can probably do the other way around. Slices contains existing role. That's an error. Okay, lowercase there, and then the role name. So that handles that. Then we need to quickly append it to the list. That's the duplicate detection. So slice contains, and we said we want management cluster instances. So that would be to validate the role itself. It's not supported. Okay. All right, I'm missing an import. And that should be it for validation in theory. Can go and check that. So I can push the binary. Should actually be here, IncusOS demo OS root. Okay, just starting a second terminal here, going inside of our IncusOS VM and doing the usual trickery. And then we can bounce IncusOS, whatever that is. I can probably just do this. Did that get it? Yep, it's restarting. System is ready. Good. Now let's get another terminal. Incus query demo. Just let me get shell in there. It's gonna be easier. Or maybe not. Yeah, actually, it would benefit from being able to talk to it directly. Let me just remove some stuff in here. Yeah, demo OS was defined. Okay, so I'm just gonna be adding a remote for it. Demo OS. I'm gonna need its IP address here. Okay, because now what that lets me do is I can do demo OS 1.0 system network. If I don't make a typo here, that gets me the network config we currently have. I can write it to network.json and we can go and edit it. So let's first try putting management twice. Okay, interface 0, role management is listed multiple times. Cool, that works. Now if I do management and foo, unsupported, that's fine. And let's do management and instances, that should be valid. Yep. And now if we go look at its output, it should be good. Yes. All right, so that's working. Now what we need to do is actually go and get this part here to populate correctly. That's potentially going to be slightly tricky in some scenarios when we're dealing with bonds and a bunch of other things. But yeah, in general, it should be interfaces, the name. From that, we can look up this guy based on its name property, and we can get the roles list, and we copy that roles list. That's the first pass. And then the second pass is actually assigning roles when they're missing. Like in this case, we don't have anything with a clustering role, so everything that has the management role should now get the clustering role. And then will be the kind of final state of if there's no management role, then we should look at which one of the interfaces are functional, like they're actually online, they're routable and everything, at which point we'll assign management and clustering to those. So that's kind of the idea. Let's see if we can get that done, at least part of it, pretty quickly. First, I'm just gonna go, so my Incus OS, I just want to put static analysis, see if the current change is good. If it is, then can at least commit that. Yeah, all clean. So let's commit Incus OSD systemd add valid actually systemd network d add validation for roles. Okay, very good. Next was my editor up here. Okay, so we want to look at what generates the state. I don't remember. Like that API was mostly written by Matthias, so I've not played with it directly too much. But if we look at get calls update network state, and then that updates the internal state struct, and then we effectively return the combined version of that. So I think update network state is probably what we want to go and look at, which is again in the systemd network d package here. And let's go see what does that do. State update for interfaces, for bonds, for VLANs. Okay, so it goes over the config and then it fills in based on the interface name the details. So that makes sense. Now how do we handle the, like, what's the best way to handle this stuff? Because the difference here is that we need, I mean, just copying stuff around, that shouldn't be too bad. Get interface state is what we're going to be using for that. That's easy. It's mostly thinking of the next step, where it is about making sure we've got a given role and then going back and updating things. So we're probably going to need to fill everything in that way and then do another loop on top of end.state.interfaces to actually one or two loops, or maybe three, who knows, to actually go around, see what we have, what we're missing, apply it, and potentially do another pass. Anyway, for now, we need to fix get interface state to go and copy things for us. What does it do in Nifta? Get interface state takes i.name. It's not gonna have access to much, I don't think. Yeah, it just pulls the state from network D, I bet. It doesn't do much more than that. Okay, so we might not actually want to do it in that function. We might just need to do it the old-fashioned way. So just do interfaces i.name and then set it to, do we have access? What do we have access to here? And API system network. Okay, that should be enough. So yeah, we need the config n.config.interfaces oh, no, never mind. I'm stupid. Okay, what we literally need to do is just this. I think that should do the trick. Just checking that this should be fine. Yeah, and here too. Let's see if that builds. It does not. What's it saying? Cannot assign to struct field in map. Huh? It's in one of those cases like it's not a pointer, so since it's not a pointer, we can't just go and mangle it that easily. That's slightly unfortunate. Okay, I mean the way around it normally is to effectively get. Okay, let's just do the first one and try to do it cleaner. So at the end of the day, we need to set this guy. So n.state interfaces i.name is what we want to set to iFace, well, I'll call this with iState, interface state. Okay. This gets us an initial iState like this. And then iState.roles, we want to set that to i.roles. So basically something like this. Yeah, and that does build fine. Okay, good. So now rinse repeat with these two, something like that. And we just need that to define it as state. Same thing here. Okay. Oh, do we using different iterator? Yeah, we are I, B, and V. Okay, cool. That doesn't really seem particularly needed, but sure. I mean, at that point, let's just do it for all of them. So that becomes B state and B and B and B. Okay, sure. Just trying to minimize the number of changes. Like, it's tempting to just rename everything to I at this point so that it's easier to copy paste, but I don't know. Maybe we wanted to be able to copy paste that logic somewhere else. Who knows? Okay. So this is built and that seems fine. So let's go and where's our VM here? Mount of this guy. I need to remove the binary, push the new binary, bind mount it, pick it. Okay, so that should restart it. Yes. And if we look at the state, hey, look at that. The roles are actually showing up. All right, so the basic of just passing through the existing roles, that works. Good. Let's go static analysis quickly. Make sure this was all clear and can commit that one. Yeah, fine. Okay. Next, actually gonna check what we've put here. So validation, that's fine. That's fine. So these two steps we actually have. The next is kind of ensuring that we do have management and cluster roles set. So for that one, what we would do is ensure required roles exist, I guess. Okay, something like that. While we're setting those, we could go and just flag effectively whether we have the given roles that we need. That's probably the easiest to avoid kind of needless iteration to an extent. So let's do like a roles found list like that. I'm just thinking because like it's tempting to just append them all in there and then do a contains and call it done. It means we're gonna have duplicates in there, but that is probably not really an issue. Yeah, it's pretty tempting to just do it that way. That would be easiest. So what we do is like roles found, append roles found, i.roles, something along those lines. Okay. So we effectively need to go and apply missing roles only if we don't have management and cluster already set. So the way I would do it, it's kind of tricky. Well, tricky to do it in an optimal way anyways. Let's just do it whichever way now and can optimize later. So roles found. So if we don't find management or we don't find cluster, then we're gonna need to go and do some fixing up. So we iterate over the interface states. And we effectively get I state is, I in this case, then I state dot. I'm just gonna do it very wrong initially, just to see if the overall logic is fine. So we'll do something like that, and then and that state interfaces name is I state. Okay, so that builds. Just make sure this works. Like, I know this is wrong as far as the logic goes. It's mostly to just be able to test it. So in theory, I would expect it to have cluster now. Yep, it does. It effectively noticed that changes were needed and it went and just overrode the interface. Okay, so that's fine. Now, obviously we need to be a bit more clever than this because all we know at this point is that some stuff is missing management or cluster. We don't really know which is a bit of an issue. But that should be okay. So basically what we want to do is, so if we're missing management, then and the interface I state dot state is routable, then we want to add the management role. The problem is that the role could be null. So if it's null, we need to initialize it. Okay. And then after that, we can do the shared logic of roles, append, state roles, management. So that should add the management role when it's missing. And then what we would want to do is, if we're missing the cluster one, and the interface we're looking at has the management role, then we want to add the cluster role to it. So that's basically the logic we should have, I think. Let's see. Yay, that builds, so that's a good start. Amount, wipe the thing, push the binary, bind mount it, restart. Okay, so this time around, the config before was management instances, so it was missing cluster. We should have management cluster instances, or whatever order at this point. And we do. Okay, so that's looking good. Now, if I go and do an oops, if I get my config here, and we only put instances. So if I put that in place, I should have the same output effectively. Except I think as far as order, we would have instances, management cluster. Yep, exactly. So that's working fine. And if we had more interfaces, then things would be a bit different, obviously. Can I easily get myself another interface over there? Probably. Just so we can play a bit. So demo OS, CTH1, NIC, and connect it to the other bridge that I'm not using right now. Okay, so it's got the second NIC now, which we can't see. But if we get its MAC address, which is here, then we can edit the config to include it. So interfaces, that would be the first one here. Okay. Let's call it, I'll just call it dummy. Its MAC address is this. Okay. And let's not even bother with addressing. So just empty address list, just basic MTU and role. Let's give it the cluster role. So if I do that, that's actually an interesting one. So what would happen? It says instances, clusters are in place. So it should not apply the cluster role anywhere else. But then this one would get rootable, the other one would not. So this one would then get the management role. At least that's what I would expect to see. Let's try it. Okay, apply the config, query. What are we looking at? Dummy has the cluster role. Management has instances and management. So that's as expected. All right. And if we started that system with no role whatsoever, then we should get management cluster on the first one, on the management interface, and nothing on dummy. Let's see. Management cluster, nothing on dummy. So that's working out. All right. So that code is actually working fine. Let's just see what that looks like. So we're adding all the roles for tracking. And then if we're missing management or cluster, we go over the interfaces and we go and mangle them effectively. Yeah. Like the problem with that loop is that it literally modifies everything. Which is not really an issue, but I'm just wondering if we can make it skip if there's nothing changed. But yeah, it's not really a problem. Like on very busy systems, it's only gonna trip in a few cases, and it's not gonna slow things down. It's not an API that we need high performance on, so it's kind of pointless optimization to tweak that. Not worth the effort. All right, missing white space on 146. Okay. Why does it want the white space? Oh, here. Okay, sure. Usually the syntax we tend to use for that is something like this instead. Okay, so something along those lines. Then static analysis is clean. Okay, I can just mention automatically apply network roles. So that takes care of that part. Cool. And show, okay, so that part is fine. Then there's an internal logic which is trying to figure out what's the management interface. So that would be something that needs updating. I can go look at that real quick. So we're basically getting to the end of this time slot for the live stream. We look for management address is what we have here on the states tract. Just checking if we got other functions. There's just the host name. All right, so yeah, this function here, that's a weird syntax we went with. I know why we did, because there's a new check in the CI now, but that syntax would have cleared and be a bit cleaner anyways. Management returns the preferred IP address at which to reach the server for management purposes. Nil value is return if none could be found. Okay, so we go over the state for the interfaces. We attempt to get IPv4, IPv6, and then we return what we find, preferring IPv6. Okay. Yeah, we should effectively, since it's management, we should literally skip anything that doesn't have the management roles. The management role applied. So network state interfaces. So it's basically as simple as skip if missing management roles. Okay, that should do the trick. Actually, I'm in the wrong shell. Okay, we're missing slices in that particle file. Okay, so that's that simple. It's written in Go. I'm just seeing some of the questions going on back and forth. Yeah, Jared is taking care of answering a lot of the questions there. All right, so can commit that one. So that's Incus OSD state use interface roles in management address. Okay, which then clears this guy. And wanted a helper to get a list of interfaces for a given role. Okay, so that should be easy enough to do. Probably in the same thing here. I mean, that's on the state struct itself, which is not exactly what we want, actually. We want to do it more at the API level. So let's do API system network. And then we have system network state, which is probably where we should do it then. Where is network state? Network state is here. With a list of interfaces, that's a map. So yeah, the list of interfaces, we can't put a function on it, but we can put a function on that. So we can do func and network state get interfaces by role, and then role is a string, and that gives us a list of those. Just checking what's in interface state. Do we have the name in there? No, we don't. Okay, well, that's kind of unfortunate. It literally returns everything except what we want. So get an interface. We'll do names by role. So instead, it's going to be a list of strings, and then that can be used to query the details. Okay, so we'll just do that. We'll just do a list of strings and do a simple loop of state and range over interfaces, then if slices contains istate roles, the role we want, then we just append the name to the list and return the names. And we need a doc string on this guy. Okay, something along those lines. Let's see if that builds. Nope. Once again, no import, missing the slices import in this one. Okay, now that builds. Static analysis. Looks happy. And that's going to be in the API package. So the idea here is that operation center that consumes that API package can just use the function. So it's not really for our internal use, it's literally for external use in this case. Okay, so that takes care of the helper part. And I think there was another request of using constants for the actual roles. That makes sense. So we should probably go and do that as well. That would also be in the API, most likely, that we would do that. So system network interface role, I guess. It's going to be a long last name, but system network interface, because we would have role management, role cluster, and then role, what's the last one? Instances. Don't remember if we can bulk define cons. I think we can. Yeah, that should be fine. So let's just do that. And then the doc strings. Which are going to be quite pointless, but that's fine. That's how I usually make them. Because in the doc string is not really the right place to start explaining what roles are. Need to fix this one. And fix that one. Does that build? Yes. Now we need to actually make use of those. There's static analysis here. No, in this one. Okay, just making sure static analysis is happy. Looks like it is. We're good. So that the Incus OS the API add consts for interface roles, and then we need to actually make use of them. So let's look for anywhere we've mentioned management, I guess, would be a good one to grab for. Okay, yeah, there's a bunch of places now. Okay, so let's do this guy. Let's do that guy. This guy here. And that one here. And let's go find them all. It ironically makes the string so much longer, but hey, at least we get to use some shared logic should we ever want to change it, I guess. API dot. So that was this one management? Yeah, it was management. Okay, fine. Same thing here. Same thing here. And then we've got a couple of clusters here. It actually makes me wonder if we've got a cons for the rootable thing. Let's see. Rootable. That's a state test. iState rootable. No, I guess not. So that's fine. I'll just keep it the way it is. Was there any other management in this file? Nope. This one doesn't matter. This doesn't matter. Yeah, I think this one I'm just gonna keep the way it is instead of using the consts because that's in the middle of a test. But those should use the new constants. So this guy, this guy, and that guy here. Okay. So management, the remaining ones are fine. Cluster is never used. Effectively, instances is it's also inside of a test, so that should be fine. Okay. Go build this guy. It's fine. All good. Let's do static analysis. Looking fine. Okay, so that should take care of that too, which was the comment on the PR. And yeah, we should be good to go. So let's just push that. Go over here, compare Incus OS. And just need to actually have it close our issue here, and let's go. So that was pretty nice and easy. That should make our lives a bit easier as far as like being able to reason about all of the different interfaces that we have. Like part of the idea is that when we initialize Incus, for example, we should look at all of the interfaces that are marked as instances and automatically enroll those as managed interfaces that you can attach stuff to easily. Same thing as I said, like for operation center, it's good for it to know what interfaces are the management ones so that it connects to the right one, but also so that when it sets up things like oven or networking mesh or that kind of stuff, it can use the cluster role if it's been applied by the user to a specific interface. So yeah, that cleans up a bunch. Testing is going to take another 40 minutes to go through all the tests that we have, but then that should be able to get merged. I also saw that Matthias has the new security API up and running. I'm just going to close a lot of issues. It basically adds an endpoint to handle recovery. So if you boot with the recovery key and there's an issue because of the TPM being in the wrong state, now we've got a way through that API to fix it. So that's fine. Then we've got the API will actually show the state of the TPM for the given volume. So it will be convenient to make sure everything is clean. It also adds an API to just see the state, the encryption state of everything. And I think it also adds an API to keep track of the secure boot certificates. So that's gonna clean up a lot of things in one shot. That's very good. Yeah, running into some weirdness with the linter. I've kind of noticed that issue myself too. Occasionally they've got two different linters that test the same thing, and we get errors one way or the other. Also depends on the Go version sometimes. So anyway, I'm gonna need to review all of those commits, but that's gonna close like 4 issues. I'm closing 1 issue with mine, so there's not gonna be a ton left open. We've got some bigger pieces we still need to look at. Then some performance stuff around the text UI, The storage API is going to be a bigger one that we'll want to work on. But yeah, those two pull requests are going to clear a bunch of the backlog. Basically, I guess all of those are going away. This one I can actually close, I forgot, because that's done now. So let's close that. And let me just quickly look at the chat. I've seen a bunch of back and forth, so I think most should be covered, but let me just check if there's any question or anything to comment on. It was mostly around, what Incus OS is and what's this whole effort. So I think that's all good. Yeah, no, I think everything was covered in the chat. Alrighty, so that's it for this live stream. I think, hopefully it was a good update on where we're at with, with Incus OS. I just saw a failure here. Let's see if I actually did run into interface role storage. Interesting. Yeah, I forgot about that. We actually do have a storage role. Never mind me finishing the stream right now. I'm just gonna go and fix that one real quick. API here. So the storage role is meant to access storage arrays, whether it's IceCozy or NVMe/TCP or the like. I completely forgot about that one existing. So let me fix that. Role storage. We can effectively go and merge that one with the list of cons here. And then if we go look at, where is it? Yeah, in here. No, it's in the validate function. Never mind. Validate role. Yeah, in here. So I need to add the storage role to that list, and that should do the trick. Like it's kind of like instances. It's not actively used by any of the internal functions right now, but it might be used by IncusOS, by Operation Center in this case. Just checking that this whole build does. And if I go and rebase this, validation rules for roles, so that goes. Whoops, that's gonna be a problem. Okay, so this actually goes with this one, and this one I need to edit. It's an issue when you're trying to keep a tidy tree. You kind of need to do stuff the wrong way just so that it can be fixed by the next commit correctly. So that's one of those cases. So I'm just fixing up the old commit, and then I can continue the rebase, and it's gonna probably fail on the last one. Then just need to resolve the conflict here. By turning that into storage. Like this. So if we look at the full diff, that's looking good. And then continue. And we're good. Okay. Do a quick static analysis, run locally. We're good. And can force push that, and we should be good to go. And there we go. So that's the new set of commits with that thing fixed. Adding the validation, passing through the configured roles, making sure we apply missing roles automatically, making use of that in management address, adding the helper function in the API, making sure you've got consts for everything, and making use of them. So yeah, that's it for this live stream. If you've got any questions around any of this, feel free to leave them down below in the comment section. You can go in our community forum. We're making good progress with Incus OS. I think most of the blockers we had to having people more actively use that on actual machines are basically gone by now. We just need to finish the key rotation, and then we'll probably start posting on the forum soon with, hey, you can play with the flasher tool, you can start using it on some machines. We don't expect the signing keys to change. We don't expect to break the configuration storage anymore. And we're effectively kind of good to go from that point on. There's going to be gaps, missing features, missing stuff. We can add those, but we should be able to do that without like having a hard break day where we break all existing users, as we have on occasion so far. All right. Thanks for watching. I'll see you in another live stream next week before I go on break for a little bit. Just another failure, so gonna be babysitting things until it goes through. This is a role that we don't actually want to use right now, so I'm gonna drop that one and from the test, and we'll be good. Thanks for watching. See you in the next one. Bye.